Now question number 33. A gas is compressed from 10 meter cube volume to 4 meter cube volume at constant pressure of 50 Newton per meter square. Then the gas is heated by giving it 100 joule of energy. The internal energy of the gas will be: first, increases by 100 joule, second, increases by 200 joule, third is increases by 400 joule, fourth is decreases by 200 joule. Now see how to do this one. As per the given question, initial volume was 10 meter cube. Now the volume become your 4 meter cube. So V1, 10 meter cube, it compress to V2 volume 4 meter cube at constant pressure as it is given, at constant pressure. Then it is heated by giving 100 joules energy, and pressure also given here 50 Newton per meter square. Then gas is heated by giving 100 joule of energy. The internal energy of the gas will be: the first of all, when it has been done, so work done in this process, the work done in this process, your pressure into change in volume. Pressure your 50, change in volume your 10 minus 4, 10 minus 4 means 6, so that is your 300 joule. So 300 joule is the work done. And next is how much heat? Heat has been supplied. Heat has been supplied to the gas here only 100 joule. Heat has been supplied 100 joule. From first law of thermodynamics, from first law, Q is equal to delta U plus W. Q is your 100, delta U plus W your 300. So delta U is minus 200 joule. It means 200 joule of internal energy has been decreased. So our option number 4 is the correct option. Question number 34. The different substances have their specific heats in the ratio 2:3:1 and their temperatures are increases in the ratio 3:1:2:2. If the same quantity of heat is supplied, find the ratio of their masses. First is 5:6:7. Second is 3:2:6. Third option your 1:2:3, and the fourth option 4:7:9. The first thing, the relation between their specific heat is given as 2:3:1. It means let C1:C2:C3 2:3:1, and their change in temperature is 3:1:2. Their change in temperature delta T1, delta T2, delta T3 is given as 3:1:2. Now same heat, Q is same. If Q is same, so we have to find M1 ratio, M2 ratio, M3 we have to find. So when heat has been given same, so Q is equal to M1 C1 delta T1. That is also equal to M2 C2 delta T2, M3 C3 delta T3. So now M1. From here we can say that give us C1 by C2 2/3 and C2 by C3 is your 3/1. So let C3 is your C. If C3 your C, the C2 will be your 3C, and when C2 or 3C, the C1 will be your 2C, like this. Similarly, so M1, C1 we can say 2C. Similarly, if delta T2 is equal to let theta, so delta T1 will be 3 theta and delta T3 will be 2 theta. So M1, C1 is your 2C, delta T1 your 3 theta. M2, C2 here 3C, delta T2 theta. M3, C3 your C, delta T3 your 2 theta. Now simplify. So this gives us M1, 6M1 is equal to your 3M2 is equal to your 2M3. So from this we can write M1 by M2 is equal to your 1 by 2 and M1 by M3 is equal to your 1 by 3. So if M1 is M, so M2 will be your 2M and M3 will be 3M. So ratio of M1, M2, M3 here 1 to 3. So M1 ratio, M2 ratio, M3 will be your 1 ratio 2 ratio 3. So our correct option here, option number 3 is the correct option. Question number 35. In this problem, we have to match the column 1 with the column 2. In the column 1, certain processes or some certain conditions are given. In the column 2, we have to match those conditions. In the column 1, first is given delta Q is equal to delta U. Second is given delta Q is equal to delta U plus delta W. Third is given delta Q is equal to delta W. And the fourth is given 0 is equal to delta U is equal to delta W. In the column 2, one is given isobaric process, another given isothermal process, third is given adiabatic process, and fourth is given isochoric process. So in these we have to select which of the option or which of the column list in the column 1 matches with the list in the column 2. So see here. First, if I am talking about column 1 and here column 2. In the column 1, A given delta Q, delta U. B given delta Q, delta U plus W, and C given delta Q is your delta W, and D given 0 is your delta U is your delta W. And in column 2, first given isobaric, second isothermal, isobaric, then isothermal, then given here adiabatic and isochoric. Adiabatic and then isochoric. See, here delta Q is delta W. A, first see the A. A means here, well, according to first law of thermodynamics, from first law of thermodynamics, from first law, delta Q is your delta U plus delta W. In the first, delta W is 0. In work done 0, work done 0 means volume is constant. Volume constant means process your isochoric. A is your H. Similarly, if we are looking B, in case of B, delta Q your this, so that is your, can be your isobaric. In case of isobaric, there is nothing change. So this will be your E. C. Delta Q or delta W. Delta Q or delta W, change in internal energy is 0. The temperature of the system your constant. So isothermal. And the D, in which delta U is 0, delta W 0. It means neither energy changes nor here. So delta Q is also 0. Delta Q 0 means for adiabatic process. This AH, BE, CG, DF. So our option, we can check AH, BE, CF, DG. Option number 4 is the correct option. Now, question number 36. It is given as 10 gram of ice at minus 20 degrees Celsius is dropped into a calorimeter containing 10 gram of water at 10 degrees Celsius. The specific heat of water is twice that of ice. When equilibrium is reached, the calorimeter will contain. First option, 10 gram ice and 10 gram water. Second option, 20 gram water. Third option, 5 gram ice and 15 gram of water. Fourth option, 20 gram ice. In a calorimeter, 10 gram ice at minus 20 degrees Celsius, and another given here 10 gram of water at 10 degrees Celsius. 10 gram water at 10 degrees Celsius. So first we will check it, how much ice required heat to reach from minus 20 to 0. See, amount of heat required for ice to change its temperature from minus 20 degrees Celsius to 0 degrees Celsius. That is your M S delta T. M given here 10, S is your C, delta T your 20, that is your 200 C. Now, amount of heat supplied by water to come down its temperature, from 10 degrees Celsius to 0 degrees Celsius. Q dash M S, specific heat of this is your double of the water, delta T or 10. So this also comes your 200 calorie. It means when water temperature decreases from 10 degree to 0, it will supply 200 C calorie, and that heat is sufficient to just increase the temperature of ice from minus 20 to 0. So both are now reaching at 0 degrees Celsius, this is also 0 degrees Celsius, and thermal equilibrium achieved. So finally in the mixture 10 gram ice at 0 degrees Celsius and 10 gram water also at 0 degrees Celsius. So our answer is your option number 1 is the correct option. Question number 37. A calorimeter of mass 200 gram, specific heat 0.03 Celsius units, contain 30 gram of ice at 0 degrees Celsius. When certain amount of steam at 100 degrees Celsius is passed into the calorimeter, the mass of the calorimeter and its content are observed to be increased by 9.1 gram and attains a resultant temperature of 80 degrees Celsius. The latent heat of steam we have to find. So now see how to do this problem. In this given a calorimeter, and this calorimeter have mass 200 gram, and right now 30 gram ice at 0 degrees Celsius is kept here. Here 30 gram ice at 0 degrees Celsius, and specific heat of the calorimeter container is given 0.03. Now some steam is supplied here. After supplying some steam at 100 degrees Celsius, the total mass increases by 9.1 gram. 9.1 gram mass has been increased, and final temperature here your 80 degrees Celsius final. It means what the steam does, steam at 100 then reaches at 80, and 9.1 gram steam has been supplied. That's why the increase of the mass is this. So heat supplied by steam, that is equal to your M 9.1 latent heat of steam plus 9.1 specific heat of water into 100 minus 80. So this is your 9.1 L plus 20 into 9.1, 182. This is the calorie. This much heat has been supplied, and that heat goes to the heat taken, that is equal to container 200 gram, it goes to up to 80 M S 0.03 delta T 80 plus ice first melt ml 30 into 80 plus ice temperature, ice converted into water, it goes up to 80 ms delta T m S for water delta T 80. Now we can simplify this. So this is your 6 into 80, 480 plus this is your 2400, 4800. So calorie, this total is your 5280 calorie. This and this will be the same. Now from principle of calorimetry, we can write here 9.1 L plus 182 is your 5280. So 9.1 L is equal to 5098. The L is 5098 by 9.1. 1. L is equal to your 5098 by 9.1, and that is approximately here 560 calorie per gram. So our answer is your option number 2 is the correct option. Question number 38. A lead bullet of mass 50 gram initially at 20 degrees Celsius. The specific heat of the lead is given 0.03 calorie per gram per degree Celsius. Is fired vertically up and with an initial velocity of 400 meter per second. When it returns to the point of projection, it strikes an ice block at 0 degrees Celsius. Assuming that all the energy is spent to melt the ice, the mass of ice melted is: first option 50 gram, second option 51.5 gram, third option 49.6 gram, and the fourth option 12.2 gram. As per the question here, this is the lead, a block of ice. From here a bullet of mass 50 gram at 20 degrees Celsius. Mass 50 gram projected with velocity 400 meter per second and temperature of the bullet here 20 degrees Celsius. So when it come back here, so total energy it loses. The final temperature of this will be a 0 degrees Celsius. Loss of energy by bullet is half mv square plus ms delta t or theta, and that energy is utilized to melt the ice. All we can convert into the quantity we can convert into the calorie. Half mass 0.05 v square 400 square. This is in the joule, so convert into calorie. So 1 calorie of 4.2 joule. So 1 joule your this by 4.2 calorie plus m your 50, s 0.03, and delta theta is your 20 degrees Celsius. Now we can simplify. 5 by 8.4, this is your 1600 plus this is your 3 into 0 cancel 30. This is the loss of energy and this in the calorie. So amount of ice melt, this we can simplify. 80 by 8.4 into 10 power 2 plus 30. So that will be your into calorie. So amount of ice melt, m into L is equal to your this 80 into 10 power 2 by 8.4 plus 30. So m is equal to your 1 by 80, and this is your 80 into 10 power 2 by 8.4 plus 30. When we are solving, it will come around 12.2 gram. So this is our option. So option number 4 is the correct answer. Question number 39. This is a matrix matching question. So in the list 1, certain situations are given, and in the list 2, some temperatures are given. So in the first list A option, when 1 gram of steam at 100 degrees Celsius is passed into the 3 gram of ice at minus 20 degrees Celsius, the temperature of the mixture. So we will solve this here one by one. If we are looking the first A option, in this option 1 gram of steam at 100 degrees Celsius. 1 gram steam at 100 degrees Celsius is passed at ice at minus 20 degrees Celsius. Minus 3 gram ice at minus 20 degree Celsius. Then we will check it. First of all, let final temperature is, or we can say first, how much heat. Final temperature is, let theta degree water. So heat supply by heat gain. Heat supply by heat gain. Heat supply is steam. First ml, M is 1, L 540 plus 1, S is your 1, delta T here 100 minus T. Now heat gain. First ice melt, before that reaching minus 20 to 30. M S 0.5 delta T 20 plus ice melt, ml 18 to 3 plus now convert into water, 3 gram water into us, then T minus 0. Now we can simplify. This will be 540 plus 100 minus T, 640 minus T, and this is your, we can check, 30 plus 240 plus 3T. Now we can equate. 640 minus T is your 270 plus 3T. The 4T is equal to 640 minus 270, which is your 0, 7, 3. 370. So T is equal to your 370 by 4, 92.5 degree Celsius. The final temperature of this here 92.5 degree Celsius. So in the option, first is approximately, we can say 100 degrees Celsius. So option number 4 we can say. The A is approximately your option number 4. 4 means here it is given your H. Similarly, we can go for the other also. So in the given option, only the option number 1 is your H. In the same way we can get. So your answer number 1 is the correct option. Now question number 40. In the question number 40, n number of liquids of masses m, 2m, 3m, 4m and so on, having specific heat S, 2S, 3S, 4S and so on, at temperature T, 2T, 3T like that, respectively are mixed, then the resultant temperature of the mixture is. First option 3n by 2n plus 1T, second option 2n plus 1 by 3, 2n plus 1 into T, third option 3n n plus 1 by 2, 2n plus 1T, fourth 3n n plus 1 by 2n plus 1 into T. When all of them are mixed together, so change in internal energy of mixture will be 0. Change in internal energy of mixture will be 0. So let final temperature is T. That final temperature is T. So n number of liquids are there. So first M, Specific heat of that your S delta T, T minus T. Next, 2m specific heat 2S, 2T minus T. Third, 3m, 3S, 3T minus T. Likewise, we can say is equal to 0. See here, ms, T if we are taking common, 1 plus 2 cube plus 3 cube, then 4 cube you will get like this, equal to your MST as a common, 1 plus 2 square plus 3 square like this. So T is equal to your sigma n cube by sigma n square into T. This is the answer here. So after putting the value of sigma n cube and by sigma n square, we will get option number your third is the correct option. This is our option. Question number 41. The question is given as a thermally insulated rigid container contains an ideal gas at 27 degrees Celsius. It is fitted with a heating coil of resistance 50 ohm. A current is passed through the coil for 10 minutes by connecting it to a DC source of 10 volt. The change in internal energy is first option 0, second option 300 joule, third option 600 joule, fourth option 1200 joule. Change in internal energy. Change in internal energy. Internal energy is equal to your electrical energy dissipate. Electrical energy dissipates across given resistor. So, change in internal energy is equal to your V square by R into T. And V is the potential applied, which is your 10 volt. 10 square, resistance your 50, and time is given here in 10 minutes. To convert 10 into second, so 10 into 60, so this will be your 100 into 10 into 60 by 50, so this is your 1200 joule. So change in internal energy your 1200 joule. So our correct option, your option number 4, the fourth option is the correct option.